So in this video, we'll spend a little bit of time trying to decide if we can determine the principal value for each inverse trig expression, and then also determine another value that's not necessarily one of the principal values that is within the interval that's described in part B. So if you look at this first one here, we have inverse cosine of -1/2. Now, if you're in a situation where you can use the calculator, you can type this into the calculator and you will get an answer, but you won't be able to develop your answer for part B without one. So we're just going to kind of go without a calculator from start to finish here. The process that I like to try to use here is to get this to depend on the normal trig function rather than the inverse trig function. So if I take the cosine of each side of this, right, I'm trying to figure out inverse cosine of -1/2 is equal to something, so I'm trying to fill that blank right there. I can take the cosine of the left-hand side of the equation, cosine inverse cosine cancel, I'm left with -1/2, and if I do cosine of the same blank, I need to figure out what to fill that blank with that gives me an answer of -1/2 for cosine of that angle. So if you use the unit circle to try to reason this out, you're going to have to recognize that cosine is determined by the x-coordinate, so you need to go to a location where the x-coordinate is -1/2. So if you have used the unit circle this way a decent amount, you hopefully realize that if you take the ratio for the sides of a 30, 60, 90 triangle, 1, 2, square root of 3, and you divide by the hypotenuse, what you end up with is you end up with a value of 1/2 over here. So I'm going to try to draw a 30, 60, 90 triangle so that my x-coordinate, and the reason why it's the x-coordinate is because we want cosine to equal -1/2, so that my x-coordinate is -1/2. So if I draw a 30, 60, 90 triangle into the second quadrant, and I drew it into the second quadrant for two reasons. I need the x-coordinate to be negative, and I need my answer for part A to be a principal value. So the principal values for inverse cosine are highlighted in blue here. We're going to have to get a value that's between 0 and pi as our end result for part A. So I drew my 30, 60, 90 triangle into the second quadrant. And what I have to try to do is I have to try to figure out what this angle is right here that I'm opening up with from the positive x-axis. That's going to be my answer for part A. So what I realized was that in order to draw the triangle so that the short side was along the bottom and the longer leg was vertically working up into the second quadrant, I had to have the larger angle as the base angle down here on the bottom and the smaller angle as what I have up here in the top. So I realized that this angle right here was 60 degrees. And I know that if I go clear from x-axis to x-axis, I'm going 180. So I'm 60 degrees shy of 180. So in degrees, I'm looking at 120 degrees. If I want to convert that to radians, I can use the conversion factor, a little dimensional analysis here. I've got pi radians per 180 degrees. If I do top times top, I get 120 pi. If I do bottom times bottom, and this is over 1, I get 180. And then I just have to try to reduce that thing. So if I divide 120 and 180 both by 60, I end up with 2 over 3 with a pi stuck in that numerator. So that is my answer that sits in the second quadrant. Now in part B, we turn around and say, okay, well, let's try to find another answer for this that the calculator won't give you. We want this answer to be between pi and 2 pi. So I still want cosine to equal -1/2. But now my angle, my answer, has to be between pi and 2 pi. So I highlighted in red on the unit circle what stretch of the circle we would have to be concerned with for part B. Here's where I'm equal to pi. Here's where I'm equal to 2 pi. I need an answer within that stretch where cosine equals -1/2. So cosine's the x-coordinate. If I think about just taking this triangle and reflecting it down into the third quadrant, my x-coordinate stays -1/2. This base angle that you see right here is still going to be the same as the base angle that's right here, still a 60-degree angle. So I thought, all right, well, this angle that I'm opening up with to get to that red radius that you see drawn into the unit circle is going 60 degrees beyond 180. 60 beyond 180 would be 240. And then I took the same approach to convert that into radians. So I multiplied by pi radians per 180 degrees. Top times top, bottom times bottom gave me this. Divide 240 by 60, you get 4. Divide 180 by 60, you get 3. Take a look at the next one within the same video here. So this one says, what's arctangent of -1? So arctangent is really the same as inverse tangent. Keep in mind that a principal value answer for arctangent has to come from the stretch of the unit circle between negative pi by 2 and pi by 2. So the answer for part A has to come from what you see highlighted in blue along the unit circle here. So I took the same approach. I said, all right, well, if I apply the normal tangent function to this side and to this side of the equation, I need to find an angle that, when I put it into the tangent function, has an answer that's equal to negative 1. So what I thought is, well, I know tangent is sine divided by cosine, so I need sine divided by cosine to turn out to give me an answer of negative 1. I know sine is given by y coordinates from the unit circle. I know cosine is given by x coordinates from the unit circle. I don't want to pick an angle. I have to stick to this stretch of the circle, remember, right? Principal values are always for inverse tangent between negative pi by 2 and pi by 2. So if I stick to this stretch of the circle and I need y divided by x, right? Sine divided by cosine. If I need that to be negative, I'm going to have to go down into the fourth quadrant where x is positive and y is negative. And if I want them to divide into a negative 1, I need the same length across the x-axis here as I have working down into the fourth quadrant. I just have to have the opposite signs, a positive for x and a negative for y. So I thought, well, if I think about a 45, 45, 90 triangle, the proportion between sides would be 1, 1, square root of 2. If I divide everything by the square root of 2 to cut it down into a triangle that would fit within the unit circle, I would have a length of 1 over square root of 2 along the x-axis, 1 over square root of 2 down into the fourth quadrant. So I drew that triangle into the fourth quadrant. I realized that my angle, and I didn't have it drawn in this time around, but my angle would have to be the angle that you see represented right here. I'm not going to go from the x-axis clear around to that spot because my answer, remember, has to be between negative pi by 2 and pi by 2. So I'm going to have to realize that I'm going down 40 degrees into the fourth quadrant. So my initial answer is negative 45 degrees. Did the same sort of conversion that we've already talked about a couple times. Multiply by pi over 180. The degrees cancel. Reduce that fraction. Divide by 45. You get a 1 in the numerator. Divide by 45. You get a 4 in the denominator. So the principal value answer for arctangent of negative 1 is negative pi by 4. Part B says, all right, now find an answer for that sits between pi and 2 pi. So I still want tangent to equal negative 1. I have to find an angle where tangent equals negative 1 that falls between this set of angles. So what I did is I highlighted that set of angles. Pi is over here on the unit circle. 2 pi is over here on the unit circle. Highlighted that set of angles in red along the outside of the circle. So I did have this little section of overlap between where I had to look for part A and where I had to look for part B. And that's actually kind of nice because if you're looking in the same quadrant for both part A and part B, you just have to specify a different type of answer. You don't have to draw a new triangle for this particular problem. So I know that my answer for part B is going to be the angle that I open up with to get from the x-axis clear around the circle to the angle that you see plotted with that hypotenuse of the triangle once again. So that if I go clear around and get back to the x-axis, I'm going 360 degrees. Well, I'm stopping 45 shy of 360. 45 shy of 360 would be 315. Once again, let's turn that answer into an equivalent answer that's in radians. So multiply by that conversion factor. You end up with 315 over 180. If you divide 180 by 45, you get 4. It's a little tricky to divide 315 by 45. If you do, you get 7. The way that I actually thought about reducing this, since it was a little tougher than the first few reductions that we've seen on this screen, I thought, well, if I go clear around the circle and get back to 360 degrees, in radians, that's 2 pi. With a denominator of 4, 2 pi is equal to 8 pi over 4. I realized I was stopping 1 pi by 4 shy of 8 pi by 4, and that's why my answer is 7 pi by 4. So you can reduce it by hand the way that I kind of talked about initially, or you can reduce it through some other logic like I just applied there at the end.